In this class, we are going to discuss about magnitude comparator and types of magnitude comparators. Okay, this magnitude comparator is also one of the combinational logic circuit. Okay, so now how to design this magnitude comparator circuit and how to make the truth table for this and how to draw the logic diagram for this magnitude comparator. Now we'll discuss all those things in that. Okay, so first of all, before going to see magnitude comparator, we need to learn about a digital or binary comparator. Okay, so first of all, we need to discuss what is digital comparator or binary comparator. Okay, so generally these comparators, that means generally these digital comparators are made up of with basic gates. Okay, so that gates are and or and not gates. Okay, remember this point. Generally the digital comparators or binary comparators or maybe magnitude comparators that made up of with this basic gates, those gates are and or not gates. Okay, so this compares the digital signals. Okay, so this digital comparators are compares the digital signals present at their input terminals and produce an output depending upon the condition of those inputs. Okay, so that means just it will be comparing the input terminals and it will be producing the output that is depending upon the conditions of outputs. What are the conditions we are having at the output side? So depends on that condition, it will comparing the inputs. That is called as the digital comparator. Okay, so what is a digital comparator? So just I will draw the basic diagram for this digital comparator. So here what is the digital comparator? Actually comparator is nothing but comparing the inputs. Okay, so here in digital comparator comparator comparing the input signals, that input signals are digital signals. Okay, it will comparing the digital signals present at their input terminals and it produces an output depending upon their input conditions. Okay, depending on the conditions of those inputs. What are the conditions we are having? Depending on that conditions, it will be producing the output. Okay, so that is called as the digital comparator. So here in digital comparator are classified into two types. Okay, so generally digital comparators are classified into two types. The first one we can call it as identity comparator. And the second one magnitude comparator. Okay, so here generally these digital comparators are classified into two types. The first one is identity comparator and the second one is magnitude comparator. Okay, so now we will discuss about what is identity comparator and what is meant by magnitude comparator. Okay, so first of all, what is identity comparator? Okay, so identity comparator, that means the name itself identity, so it produces single output. Okay, so the name itself identity. Okay, so that means so it produces single output, either 0 or 1. It will be producing the output that is single output, either 0 or 1. Okay, so for when a equals to b, either a equals to b equals to 1 condition or maybe a equals to b equals to 0. Okay, it will be producing the only one condition, no? So that condition is nothing but here, if a is equals to, that means if you are considering one input that may be a or b, if a equals to b equals to 1, that may be as we can call it as the high condition, or maybe a equals to b equals to 0, that we can call it as the low condition. Okay, so this is called as the identity comparator. Now coming to the what is meant by magnitude comparator means, so this magnitude comparator is also one of the digital comparator which has 3 output terminals. This magnitude comparator actually consisting of the 3 output terminals. Just remember it, 3 output terminals. That 3 output terminals are having the 3 conditions. The first one is equality, and the second one is greater than, and the third one is less than. Okay, so this what is magnitude comparator? Actually, magnitude comparator is nothing but it is a digital comparator which compares the input signals and produces the output equals to the three conditions. That three conditions are equality, greater than, and less than. If you are considering the two inputs as A and B, so then the conditions becomes A equals to B, and for then greater than condition is A greater than B, and for less than the condition becomes A less than B. Okay, so these are the three conditions we are having in magnitude comparator at output side. Okay, so now we will discuss about the magnitude comparator. So our syllabus we are having the magnitude comparator. There is no identity comparator for we are having in syllabus. Okay, so just we are having the only magnitude comparator. Now we'll discuss that. Okay, so here magnitude comparator is a generally combinational logic circuit. Okay, so that compares two numbers. Okay, it compares the two numbers that maybe I can consider as A and B. Okay, so here this compares the two numbers A and B and determines their relation. So that relation may be A greater than B, A less than B, or A equal to B. Okay, so that is called as the magnitude comparator. So what is the magnitude comparator? So magnitude comparator is a combinational logic circuit that compares two numbers. I can consider the two numbers as A and B. Okay, so the relation may be, that means it compares the two numbers and it determines their required relation, determines their relation in between equality, greater than, and less than. Okay, so here, so finally here I am taking two numbers as A and B, that output is having the three conditions. Okay, so these three conditions are A equal to B, A less than B, and A greater than B. Okay, so now we will see that block diagram of magnitude comparator. Okay, so the block diagram of magnitude comparator I can consider as directly n bit comparator. Okay, so in the place of n you can just mention as numbers. That means n is equals to, you can mention as 0 to n values. Okay, so that means here we can consider as the two numbers, no, A, B, and it produces the three outputs. Those three outputs are A greater than B, A equal to B, and A less than B. Right, so that means by here this is the n bit comparator, that then either maybe 1 bit comparator or 2 bit comparator or 4 bit comparator or 8 bit comparator, like that you can substitute in n values. Right, so here, so this is the general block diagram of this magnitude comparator. Now I will explain here. So in the place of n I will take it 1 bit comparator or 2 bit comparator, 4 bit comparator. Okay, so in this, first of all I can take it as, in the place of n I can consider as the 1 bit comparator. So first of all we need to discuss the 1 bit comparator. So already you knows, right, how to design a combinational logic circuit. Means we are having some basic rules in that. So that means first of all we need to consider the statement of that function. Okay, so after that how many inputs we are considering and how many outputs we need to take it. So that is the second rule. And what is the third rule? Means we need to make it as truth table, and after that we need to consider the kmaps for getting the Boolean functions, and after that we need to consider the logic diagram. Those are the steps we are having in combinational circuit for designing, right? So the basic steps we are using, okay, here also to design the 1 bit comparator or maybe 2 bit comparator or maybe 4 bit comparator. Okay, so first of all here we need to discuss 1 bit comparator. This comparator that compares the two binary bits. Okay, two binary bits. Two binary bits means here each input consists of two values, that is either 0 or 1. That means A is consist of either 0 or 1, like that B is consist of either 0 or 1. That is the two binary bits. Okay, and also it produces the 3 output based on the relative magnitudes of given binary bits. Okay, so it consists of the 2 inputs of 2 binary bits and produces the 3 outputs. Okay, depends on their input conditions, it will be producing the outputs. Okay, so here I am taking the truth. First of all, already we knows the input relations here, what are the inputs we are having, and already we need to consider here inputs and how to, and how many outputs we need to consider here, already it's getting. So now what is the next step? It's time to design, or it's time to make the truth table, right? So here totally just observe one thing. Here I am taking the 2 inputs A and B, and that A and B is nothing but having the 2 inputs actually, right? So directly we can say that here we need to consider as 2 inputs A, B, and how many outputs we are having? 3 conditions we are having. One is A greater than B, and another one is A equal to B, and another one is A less than B, right? So just observe here, already you know, just forget this output conditions, just mention here, you can observe one thing here, that is nothing but you are having, if you are having 2 inputs, how many possibilities we are getting for the input combinations, means for 2 power n formula we need to use here, then we'll get the 4 condition. That 4 conditions are nothing but 4 possibilities we are getting, means 0 0 0 1 1 0 1 1. Just now I explained, that is nothing but here this compares the 2 binary bits, and that means each input consists of the 2 values that may be either 0 or 1, right? That is called as the 2 binary bits. 2 binary bits is nothing but that is either 0 or 1. So just check it here, either 0 or 1 we need to consider. A is equals to 0 and 1, B is equals to 0 and 0. That is nothing but we need to use here only 2 binary bits for this each input, right? So now finding the output. Okay, so how to get the output, that means how to get this output means just compare the inputs. Okay, you need to, what is the main function here, what is the main aim for this magnitude comparator or comparator, that means just comparing the both inputs. Okay, so and which condition is satisfied while comparing these two, which condition is satisfied in that, just check it. Okay, so which if you are comparing these 2 inputs, which condition is satisfied in that, just check it. Okay, so here in any one is satisfied. Okay, if anyone is satisfied in these 3 conditions, then that output is equal to 1. Okay, so while comparing A and B, if A greater than B is satisfied, then you can put it in the output is 1 for this A greater than B, and remaining conditions, so that may be equal to zeros. Okay, so here just observe, I will explain how to compare that inputs. Means here this is greater than condition, and this is equal to condition, and this is less than condition. So while comparing 2 inputs, means A is 0 and B is 0. So that means if you are comparing A and B, both the values will be equal, right? This value will be 0 and this value will be 0. That means which condition is satisfied? If A is equals to B equals to 0 is nothing but that is equal condition is satisfied. So then which condition is satisfied in the output case, that condition will be put it as 1. Okay, that condition output is equal to 1 in truth table. Okay, so what about remaining conditions? Means that is equals to pass condition, that means false condition you can mention as zeros. So this is the true condition and this is the false condition, you can put it as 0 in the false case. Okay, so now comparing the second case, that is A equals to 0 and B is equals to 1. So just comparing these two values, A is 0 and B is 1 is nothing but A is less than B, right? So that means this A value must be less than the B value while comparing these two values. That means A less than B condition is satisfied, this is true condition. Comparing to the remaining condition, that will be false. Okay, just put it remaining 2 conditions as 0 and true condition will be put it as true. Okay, so now comparing the remaining next 2 cases, that is nothing but A is 1 and B is 0. So that means while comparing A and B, A is must be greater than the B, right? So that means A greater than B condition is satisfied and remaining 2 conditions will be false. Okay, and A equals to B equals to will be 1, that means both the values will be equal. So then we are getting the A equal to B condition, it is satisfied, then we are getting the true condition for this A equal to B, that output becomes 1. Okay, so this is how to comparing the magnitude comparer, that may be 1 bit or 2 bit or 3 bit. So like this way we can finding the truth table. Okay, so just that means we need to consider the inputs. After that, comparing that inputs, we are getting the outputs. Okay, so finally we are getting the output. That means totally we are getting the truth table for this 1 bit comparator. What is the next step while getting the truth table of comparator? Means we need to design the steps for this combinational circuit. Means after getting or after making the truth table, now we need to finding or we need to consider the required functionality for this comparator. So how to get that required functionality? Means by using kmap we need to get the output boolean function. Okay, so here totally we are having the three outputs. Now for these three outputs we need to consider the kmap. Okay, so first of all I have to consider the kmap for this a greater than b output. Okay, so here which kmap we need to consider for this greater than or equal or less than? Means simply we can say that here we are having the two inputs, then we need to consider the two variable kmap. Okay, so here I am considering a and here I am considering b. This is 0 1 and this is 0 1. So here first of all I need to take it as a greater than b output. In that which state we are having the minterm state, that is considered as 1, means 1 0 case. So 1 0 case is nothing but here, no. So directly you can say that the function is becomes a b greater than. This is the a greater than b function. So like this way you can consider a equal to b kmap. Okay, so this is also two variable kmap. So then we'll get the 0 1 0 1 possibilities. So then a equal to b, we are having the two minterms in that output case, that is 0 0 case and another one is 1 1 case. So 0 0 and 1 1 case. So you can consider as two possibilities. For this, what is the prime implicant result for this box? That is nothing but for this cell will get the AB, right? So and for this kmap prime implicant result is nothing but A complement B complement. So finally we are getting the output function for this A complement B complement plus AB. So this is the A equal to B condition. Now coming to the A less than B condition. Okay, so A less than B condition of kmap is nothing but again we have to consider the two variable kmap 0 1 0 1. So which condition is true here? That is nothing but 0 1 condition. So 0 1 condition means here we'll get the prime implicate. So that means A complement and B. Okay, so finally we are getting the three boolean functions for these three output functions. Okay, so by using these output functions we need to draw the, or we need to make it as logic diagram. Okay, so for this 1 bit comparator, what is the last thing? We need to design the logic circuit. Okay, so first I have to write the functions for this. A greater than B, we are getting the condition as, what is the function for A greater than B? AB complement. And A equal to B, we are getting the A complement B complement plus AB. And for A less than B, that is nothing but, what is the prime implicant result? That is nothing but A complement B. Okay, so now by using these three functions we need to draw the logic diagram. So first I have to consider the A and another one is B. Okay, we are having two inputs now. So here some of the cases we are having the complements also. So then you can consider the complement part also here. Okay, so this is the A complement and for this I can take it as B complement. Okay, so here what is the first output? That is nothing but greater than condition. So greater than condition, what is the output? Here we are getting A B complement. So this is the A and this is B complement. Okay, you can highlight it like this. So A and B complement. So this function output is equals to the A greater than B, that is equals to AB complement. Okay, so now coming to the next one is A equal to B condition, that output having two prime implicant results, that is A complement and B complement. Okay, the next in between A complement B complement we are having one AND gate, no, and the next one is AB. So A and B. For understanding purpose or for identification purpose, you can highlight it like this. Okay. So in between these two AND gates will have the OR gate. Okay, by adding these two with OR gate, so that function is equals to the A equal to B, that output is equals to A complement B complement plus AB. Okay, don't combine like this, so just separate A complement and B complement. So next one is A greater than B or A less than B. So greater than is completed, then last one is A less than B condition, that is nothing but A complement and B. Okay, so this is one AND gate. So directly we can say that this is A less than B condition, that output is nothing but A complement B. Okay, so this is the 1-bit comparator. Okay, so now in the next class we are going to discuss about the 2-bit comparator. Okay, actually in the syllabus we are having the 4-bit comparator. So directly 4-bit comparator designing is not easy. So first of all we need to discuss the 1-bit comparator and 2-bit comparator, then we'll go for the 4-bit comparator. So after that will designing steps is very easy while comparing 1-bit comparator and 2-bit comparator. Okay, so that designing steps it's very easy. Directly you have to design the 4-bit comparator means it's not easy actually. You know the basic procedure for this magnitude comparator. So by using 1-bit comparator, 2-bit comparator, you can understand easily what are the how to compare that inputs. Okay, so this 1-bit comparator of the input comparison, this, okay, 1-bit comparator of input comparison and 2-bit comparator of input comparison and 4-bit comparator of the input comparison is totally different. Okay, but if you want to write the boolean function, or if you want to make it as if you want to make the truth table for 2-bit comparator or 4-bit comparator, compulsory the basic things we need to follow the 1-bit comparator. That means you need to use the 1-bit comparator basic steps for designing the 2-bit comparator or 4-bit comparator. Okay, so this is the introduction part, that means what are the classifications we are having in that and how many parts we are having, means these are the things. So in the next class we need to discuss we will discuss about the 2-bit comparator and 4-bit comparator. Okay, thank you.